All right, moving right along into our next unit, we're going to be talking about the surface area of prisms. That surface area is, if you can imagine, just like a cardboard packing box. It's just the amount of area that the cardboard contains, right, on the outside, the sides, the top, the bottom. And we're finding the area of all of those shapes, adding it together to find that total surface area. So to first start, we have this thing called a polyhedra, and that is just a solid with flat faces. Something to note, our faces are just our 2D shapes. And the edges, those are segments that connect the faces. And we'll have a visual soon enough. A prism is a specific type of polyhedron, right? That solid with flat faces. We have two congruent and parallel bases, and those shapes will differ. And then our number of faces depends on the number of sides of the base. All right, so let's kind of go into what I mean by that. We have a bunch of different prisms on this left-hand side, right? We have triangular, rectangular, pentagonal, and that will describe the bases, right? So our bases in our triangular prism are going to be our two parallel and congruent triangles. Notice for sure we have this triangular prism sitting on a different shape, right? This thing right here, this thing in green. This is a rectangle, but we don't have two congruent and parallel of those rectangles. So we have to consider, yes, the name, but then also the diagram. The triangles are the two congruent and parallel ones. A rectangular prism, this is a bit different just because we have a bunch of two congruent and parallel bases. We could use the top and the bottom as our bases. We could use the left and the right, the front and the back as our bases. It just really depends. But you'll get the same total area for your rectangular prism regardless of what base is chosen. So don't worry about that. And then your pentagonal prism, right? We have our pentagon, 5 sides on this top and this bottom, two congruent and parallel bases. All right, just defining terms real quick in these prisms. Our bases two congruent and parallel shapes, right? Our big B stands for the area of the base, right? That shaded sky blue, area of base, shaded sky blue base. And this is where we bring back our Unit 11 formulas, right? Our area of a hexagon, our area of a triangle, our area of a rectangle, to apply in our Unit 12 formulas for our surface area. The lateral edges are the segments that connect the lateral faces. Or another thing to think about them is that they go from base to base. Oh boy. All right, so this is a lateral edge, that's a lateral edge, right, going from base to base. And then we have our lateral faces. I think the best way to describe this are the faces that are not the bases, right? The sides that are not that blue shaded shape are just our lateral faces. All right, so we have our prisms formula. We have two things. We have our lateral area, which talks about the area of our lateral faces. So it's just everything but the bases. We find that by doing P times H. P stands for the perimeter of the base. And then H stands for the height of the prism. And of course, L stands for our lateral area. Okay. And then we have our TA, which just includes our bases. So we have our LA, which is, yes, perimeter times height, perimeter of the base times the height. And then plus, in this case, we have two bases. So find our area of the base and then multiply by 2. Again, perimeter is perimeter of the base, and then height is the height of the prism. All right, let's try this, a couple of these on the back side. All right, the first prism we have on the back side is this right rectangular prism. We're given our length, width, height as 3. Let's label this again because we want to create that nice visual. 12. I'm going to kind of make this proportional, so I'm going to make 12 this larger length, 7 the width, and then that height of 3. It doesn't necessarily matter where you label these things. Your total area will be the same regardless. All right, so I always start with identifying a base. And with this rectangular prism, you can identify any of these sides as our base. But I'm going to identify this bottom one, right, as our base. So we have these two shaded bases. From that base, I typically sketch it out right away because it's going to be a lot easier for me to find this information right away and then just plug it into my formula. So my dimensions of this base are 12 by 7, right? The area of that lovely base. I want to find my big B, right, which is my area, which is 7 by 12. And then I also want to find my perimeter of the base, which I'll need for my surface area, which I add 12 and 7 and 12 and 7, and I get 38. Okay, so now let's apply our formulas. We have our LA to start, which is my perimeter times my height. Okay, my perimeter, right, which we found before, is 38. That's my perimeter of the base. And then the H. The H doesn't talk about the height of the base. It talks about the height of the prism. So the height is literally the other number that we haven't used yet. That height is our lateral edge going from base to base. So that height will be 3. We multiply the LA, or the perimeter of the base, and the height of the prism together, and we get 114. We want to find our total surface area, though, our TA, which is our LA plus 2 times our area of the base. We already found our LA, which is 114. Then we have 2 times our area of the base. Our area of the base is 84. We simplify and combine those lovely like terms, and we get 282 units squared. All right, let's step it up a gear and talk about our right triangular prism. All right, so we're asked to find the LA of our right triangular prism with these measurements. So right away, I'm going to plug in those measures based off of what we're given. So I have a 14. Oh, we can't see that well. So I have a 14. I have A is 2. B is 3, and C is 4. Okay, 2, 3, 4. Okay, and I am first going to start by identifying my base. I can identify the base based off the description or even that diagram. I have two congruent and parallel bases. So I have that lovely triangle. 2, 3, and 4. I'm going to find my perimeter of that, which I find 2, 3, and 4. Combining those like terms, I get my perimeter of 9. I'm going to pause for the area because we won't need that area of the base for the TA. Because with our LA formula, we just need our perimeter times the height. We found our perimeter of the base, which is 9. Our height goes from base to base, right, that lateral edge, and that height would be 14. Multiply those together, we get 126 units squared, right, just to find the LA. TA, we don't have to take it any further. All right, continuing on, we have a right triangular prism with equilateral bases, the side of 8 and then that length of 10. Okay, so I'm going to plug in those numbers right away. I have my 10 as L, 8 as my S. Okay. I am finding this triangular prism, right? So that helps me identify what type of base we have with equilateral bases. Equilateral meaning all sides congruent, which means I have an equilateral triangle. So I'm going to sketch that equilateral triangle out, identify those side lengths, right? 8, 8, and 8. I can find my perimeter of the base right away, adding up all of those 8s together. And then I can find my area of the base by applying my equilateral triangle formula, which is side squared root 3 all over 4. I simplify that, 64 divided by 4, and I get that 16 root 3. Awesome. So let's sketch out that formula for my LA and then my TA. And honestly, we don't have to break it up with LA and TA. We can go right into just our TA formula, right? We have our LA plus our two bases. LA is perimeter times height, and then we have our two bases that we have to add in there. Okay, so our perimeter is 24, right? Perimeter of the base, 24. Our height, going back to our diagram, that lateral edge going from base to base, that length will be 10. And then 2 of our area of the bases. Area of the base, we found 16 root 3. We simplify both those expressions. We get 240. Then 2 times our 16 root 3. Multiply those numbers outside our radical, and then tack on our radical. And that is our TA, 240 plus 32 root 3. No additional combining of like terms. We are done. And of course, I saved the best for last. Just bringing back that hexagon formula, that regular polygons. All right, finding the LA and the TA of our regular right hexagonal prism with an apothem of 9. Okay, looking right away, I can identify my base. I have those two congruent and parallel shapes, and those shapes are a hexagon. I'm going to sketch out that hexagon because I know I need to find my area and my perimeter. I'm not given the sides, but I am given that the apothem of that hexagon is 9. Creating that right angle, cool, groovy, awesome. We need to find the perimeter, and then we need to find the area of the base. Area of the base is 1/2 apothem times perimeter. So I have my apothem that I could plug in there, I just don't have that perimeter. Let's create the radius of that hexagon. In our hexagon, we have that 60-degree angle measure in that corner, so we can apply our 30, 60, 90 knowledge. I'm going to zoom in a little bit. So we have our x root 3, 2x. So I'm going to set that x root 3 equal to 9. Divide both sides by root 3 to get x by itself. And then I do need to rationalize. Multiply top by root 3, bottom by root 3, and then simplify. So I get that this little portion, right, of my side is 3 root 3, meaning this whole side is 6 root 3. I have 6 of those, so I can find my perimeter of that by taking 6 sides, multiplying by one of the lengths of those sides is 6 root 3. So my perimeter of that hexagon will be 36 root 3. That's what I'll also plug into my area of the base formula. I have my apothem of 9, and then I have my perimeter of 36, perimeter of the base, perimeter of that apothem, or of that hexagon, 36 root 3. That simplified is 162 root 3. All right. Zooming back out, we're going to find our LA and then also TA. The LA of this shape, I think that this is the easiest once we have our perimeter and our area of the base done. LA is our perimeter times our height, right? Perimeter of the base is 36 root 3. Our height, right, goes from base to base, that lateral edge, that number that we haven't used yet, of 11 root 3. We simplify that, 1,188 units squared. Our TA is at LA plus, now we bring in our area of those bases. Our LA is 1,188, and then we have to account for our those two blue bases on the top and bottom. 2 times 162 root 3. That simplified, we get 1,188 plus 324 root 3 units squared. Right? Always sketch out that base, find your area, find your perimeter, and the LA and the TA will be a piece of cake. All right, great job today, guys.